Okay. Just looking at this example 6, looking at both of these, which look very similar, you know, what do we think the 5 is doing in each case? It's a stretch. Usually the way you would say that, it's a stretch by a factor of 5. Okay? And what does it look like the -2 is doing? I mean, if you're comparing it with x squared, is that -2 inside the squared? It's not x minus 2 squared. So a minus that comes after the function it should be a down, right? So that should be a down. But these don't have the same graphs, right? So it's a matter of how you apply this. In this case, it's definitely down 2 and being multiplied by a factor of 5. But if I distribute this, what do I get? 5x squared minus 10. So now what does it look like is going on in that one? It's being shifted 10 down. It's not 2 down. The fact that it was in parentheses meant that it was actually 10 down. It's like the first thing you do is you shift it 2 down, right? That would be the first step. You would say, okay, this x squared looks like that, right? And then you multiply everything by 5, that stretches it, right? That makes it go further away from the middle. So that's what makes that 2 drop all the way down to 10. So 3, 4, 5, 6, 7, 8, 9, 10. So the parabola now looks like that. So it's like you just have to do it in order, right? First do what's inside the parentheses, kind of like an order of operations thing, and then apply the 5. That's why that graph looks like this. This one is down 2 and then times a factor of 5. And that'll make it go. I think you can look in the book. Oh, actually, I think they had us do this in the calculator. Right? Here's the first one. X times x squared, or 5 times x squared minus 2. That's the skinnier line right there. And then here's the second one, 5x squared minus 2. That's the fat line right there. So I'm not thrilled with that example, but